Okay, angle Y, well, it was the second letter listed, so it corresponds to E, so it would be congruent to angle E. They said E, F, D. Let's look at the order. E was the second letter, so we should match it up with Y. Y was the second letter. Then we went to F, which was the last letter, so that matches up to Z. And then they went to D, which was the first letter, so now it corresponds to X. On 3 and 4, state the congruence that's missing or that's needed in order to use HL. Well, we've got right triangles. In right triangles, the two sides that surround or that flank the right angle are legs. The other side is the hypotenuse. That's good to know. So they are right triangles, okay? Then our hypotenuse have to be congruent and the legs have to be congruent. Notice the congruency that's marked already are the legs. The legs are congruent. So we've got a leg taken care of. What we need is the hypotenuse. So the hypotenuse here is AC. It's not marked congruent, so that's the piece that's missing. It would have to be congruent to DF in order for our hypotenuses to be congruent. If we had that, then we could use HL. Number 4, angle, angle, side. We have two angles. We've got the angle taken care of, we've got the other angle taken care of. But now we need a side, and it's not the one between them, so not this side. You have two choices. You could either use AB, and if you use AB, it would have to be congruent to DE, or you could have instead used BC, and it's congruent and corresponding to EF. So you could use either one of those, doesn't matter which one, you don't need them both, just one. Now down below, is it possible to prove the triangles are congruent? So in number 5, the piece that we know is congruent that's not marked is the shared side. So now when I look at this top triangle, I have two sides, a single and a double dash, an angle, but it's not the angle between them, so it's not side, angle, side. So this would be side, side, angle. That's not one of our congruencies. In this case, we don't have enough information. So is it possible to prove the triangles are congruent? We would say no. Number 6. Here we have vertical angles. I've already used single arcs, so I better use double arcs on our vertical angles. So I have two angles, a single and a double arc, and then a side. Not the one between it. It's not angle, side, angle, but two sides in row, or two angles in row, and then a side. Angle, angle, then side. AAS. So I guess first of all that was a yes, using angle, angle, side. Number 7. This would have to be a right angle also. They are right triangles. Their hypotenuses are marked congruent, but you don't have a leg that's marked congruent, so I cannot use HL. But I do have a pair of single arc angles and a second pair of angles that are marked congruent in a side. It's not two angles with the side in between. It's not ASA, but it's AA and then S. So this is another yes by angle, angle, side. If we flip to the back page, tell whether that's enough information. I'm just going to draw triangles real quick. JRM, X, Y, Z. Make sure you name them in order. So JM is marked as congruent to XZ. Angle M is marked congruent to angle Z. Angle R is marked congruent to angle Y. So we have two angles, but not the side in between, so it's two angles and then a side, so it's AAS. So to whether you can use the given information, yes. For my explanation, I'm just going to write AAS. So I have two angles with a non-included side. JRM, X, Y, Z. Okay, so JM is marked as congruent to XZ. JR is marked congruent to XY. Angle J is marked congruent to angle X. Oh, that's two sides with the included angles, so that's another yes. This one is SAS, side angle and then a side. Okay, and this one, angle J is congruent to angle X. M is congruent to Z. I use double arcs on this one. So triple arcs on R and Y. This one's going to have to be a no. Oops, I don't know why I started writing it. No. For an explanation, you could say there is no AAA congruence postulate. You could say something like that. Or you could say that we have to have at least one side of one pair of congruent sides, and we don't have that. So let's take a look at number 11. So M is congruent to Z. Angle R, use double arcs, is congruent to angle Y. JM is congruent to XY. So they do have two angles and a non-included side, but it's not the corresponding one. JM should have been congruent to XZ, and they said XY. So they have to be corresponding non-included sides. So this is a no. And I can say JM and XY are not corresponding. So that wasn't the right pair of sides. Okay, now we get into some proofs. So we've got a couple givens that are marked. So I'm going to say angle ADB. Oops, ADB. And then over here, CBD are right angles. That's a given because it's shown in the picture. AB is a single dash, so it's marked congruent to CD. That's also given. I have another congruency. They share this side. BD over here that started at the non-right angle and finished at the right angle. So if I look at this triangle, I'm actually going to reverse the order and go to DB just to make them corresponding. It's the same thing. But that would be a reflexive property. POC, because it's a congruence. So now I have, looks like I have right triangles. I marked that the hypotenuse are congruent, and now I just said a corresponding angles or a leg's congruent. So now I know the triangles are congruent. So triangle ABD is congruent to triangle CDB, and that's by HL. And now they want me to say the angle DAB is congruent to the angle BCA, or BCD rather. That would be by CPCTC. CPCTC, because those are corresponding angles. A is corresponding to C on congruent triangles. We said the triangles are congruent, therefore we can conclude that they're congruent. That's what CPCTC says. Next one, some givens. We've got SR is congruent to RP, given. Angle SRT congruent to angle RPQ, given. It's not enough information, but we've got these parallel lines. It also shows that ST is parallel to RQ. And that's also given, but that's not a congruency, but usually that's used to say that alternate anterior angles are congruent or corresponding angles. Looks like maybe I have some corresponding angles this time. This angle here would be corresponding with this angle there, because they use the same transversal. So angle RST is congruent to angle PRQ. And they were corresponding angles. Postulate. So now I have, looks like two angles with a side in between. So now I know the triangles are congruent. Triangle RST is congruent to triangle PRQ by ASA. And that then allows me to state that, oh, this side up here, this ST, would have to be congruent to this side down here, RQ, because they're corresponding parts on congruent triangles. So ST is congruent to RQ because of CPC, TC. Corresponding parts of congruent triangles are congruent. Number 14. Notice it's isosceles triangle. That means these angles are congruent. Oh, those are both in terms of x. So I should set them equal to each other. Subtract 2x from both sides. add 11 to both sides. X equals 22. Now to figure out what y is, I'm going to need to plug in 22. 3 times 22 is 66. 66 minus 11 is 55. That's a 55-degree angle there. Plug it in over here. It should say the same thing. 2 times 22, that's 44. 44 plus 11, that's 55. Those are both 55-degree angles. I know all three angles add up to 180. So I can say that 2y plus 55 plus 55 is equal to 180. So y has to be 35.